in this video, we're going to look at how to use long division and to divide algebraic expressions. To be more specific, we're going to divide a polynomial by a binomial. So first, let's recall the long division process. Again, we used this in a previous lesson. So let's see if we divide numbers without variables. We are going to add variables in here, but let's first start with long division only with numbers. So if when we divide 658 by 12, so if you remember, we had a quick tip for us to remember the 4 steps that we have to do, which says, does McDonald's sell burgers? So D means divide, and M means multiply, and S means subtract, and the B means bring down. So in order to do these, long division, we have to do these 4 steps. So let's start with, first of all, when we set up, make sure so the question literally, like in this thing, we want to know 12 goes into 658 how many times. So the number 12 goes on the front, and 658 will go in the box. So because I did see some students, they had set up the wrong way. They put 12 inside and 658 on the front. That would be incorrect. Okay, so now we're going to start with the first step after we set it up, division. So when we divide, we can start with the first digit, 6. So you're doing 6 divided by 12, and or in the other words, how many times 12 goes into 6? And we know that it's 0 time because 12 cannot go into 6. So 6 is not big enough. So you can put a 0 there if you want. If you don't put a 0 there, leave a space. Now, let's look at 65. We're going to add a digit, so we're going to continue. 12 goes into 65 how many times? So this is like doing division of 65 divided by 12. In fact, we want to do 658 divided by 12, but we cannot see the answer like in one step. So we actually slow down. We first divide 6 by 12, and it doesn't work because 12 doesn't go in there. And then we add a digit. We divided 65 by 12, and 65 is bigger than 12, so we do have enough to do division. And so I'm going to show you the first step right here on the right. So like I said, the first step, we're trying to figure out how many times 12 goes into 56. It's like doing division. So does division. We divide 65. Sorry, that's a typo here. 65 by 12. And that gives us 6. And you might be able to it might be difficult to see. Actually, it's 5 times, not 6 times. But you could start with rounding the numbers, because this is not really that easy to see. So we could round 65 to 60 and round 12 to 10, and then they just divide 60 by 10. So kind of like you just ignore the ones. 6 means 6 tenths, 1 means 1/10. So 1/10 goes into 6/10 6 times, because that's much easier. But when we use 6, and the next step would be doing multiplication, you will have to multiply 12, because imagine that you have $658 and split among 12 people. If you give everybody 6 and 6 tenths, and that's going to give you 72 tenths, which we don't have 72 tenths. We only have 65 tenths. So that 6 is way too big. So we're going to have to reduce, but it's a good start. So we can just reduce 6 down to 5 and put a 5. Again, I guess this is a typo here. So we're going to put a 5 on top of the line here. Okay, and so the first step, this 5, where did this 5 come from? We divided 65 by 12, and we got, actually if you use calculator to divide that, you're going to get like 5 point something something, but we only take the whole number 5. But again, if you don't use calculator, and then you just have to round it. So 110 goes into 610. So you literally just ignore the ones digits to get 6, and if 6 is too big, reduce it down. So now we're going to put the answer 5 on top of the line and line up with the 65. And so we finished the first step, which is divide. Now next we're going to do step 2, that's multiply. And what do we multiply? We're going to take the answer 5 that we just got, multiply with the 12 people, because if you're going to give everybody 5 tens and you have 12 people, you need to figure out how much money, how many tens where you need. So we do 12 times 5, which gives us 60. So that means we need 60 tens. So we line up 60 tens with 65 tens we have, and then next we do third step, we do subtraction. So division, multiplication, subtraction. So we got 65 minus 60, that's 5 right here. So now B means bring down. So if we have any digits, we bring down the next digit, 8. And after we bring down 8, the focus is going to be this new number, 58. So we have $58 split among 12 people, and we're going to have to start over division, subtraction, and division, multiplication, and the subtraction. So we're going to divide 58 by 12. Again, you can just run it because it's hard to divide this in our mind. So you can just run it as 50 and 10. So the ones they just ignore them. So 50 divided by 10 is much easier. So just get 5. Again, 5 would be too big because we have 12 people. If you give everybody $5, that needs $60, but we only have 58. So let's reduce 5 down to 4. And then we multiply 12 and 4 instead of 12 and 5 now. And again, the 4, the quotient of 4, we're going to put it on top of the line here. So this is the 4. So that 4 means you will give every of the 12 people $4, each of them $4. So 12 times 4 gives us 48, which I already have here. So that means if you give every of these 12 people, each of them $4, that would cost you $48. And let's deduct $48 from $58 we already have, and we got $10. So that is the remainder. And so that's after subtraction, you can stop because we don't have to do bring down anymore because we don't have anything else to bring down. Unless you want to split the dimes and the pennies. Otherwise, you can stop here. So the answer is 54. So this is the long division process we did it before. Now, we're going to apply the process to variables. And if you look at this question, compared to the previous problem, 658 divided by 12, and 658 divided by 12. So the top, of course, we have not just not 6 digits, we have 6 terms. And the bottom, we don't have 2 digits, we have two terms again. The kind of format is similar. So the setup will also be similar. So if you remember in the previous example, we put 658 in the box and 12 on the front. And so we do the same thing. So we're going to take the top and put it in the box, 3x squared minus x minus 5. And then we put an x minus 2 the bottom on the front. So this corresponds to 12. This corresponds to 658. So the process is really analogous to long division of numbers. So we're going to have to do the 4 steps, divide, multiply, subtract, and bring down. That's McDonald's sell burgers. So step 1, divide. And here, since we have 2 terms, we're going to also take 2 terms and divide. So we're going to divide 3x squared minus x by x minus 2. So we take the 2 terms divided by 2 terms. And if you remember when we did this process and we divide 65 by 12, when we divide them, it's hard to do. So we just ignore the ones digits, just treat it as 10. How many times 10 goes into 60, which is 6 times. So we could do the same thing here. We can just ignore the second terms because, again, it's very hard to do division when you have 2 terms. So we're just going to ignore them and just divide 3x squared divided by x. And this is something we know how to do, and we did this before. To division, we divide the numbers by number. 3 divided by 1 is 3. X squared divided by x, we subtract the exponents. 2 minus 1 is 1. So we got 3x to the first. Okay, again, so we're supposed to divide these two by these two by whatever in the bottom, x minus 2. But because that's too difficult to do, we could just round it or just ignore the second terms to divide to get the something to start with. So we got 3x. And again, the ends of the quotient always goes on top of the line. So we put 3x here. And next, we're going to do multiplication. Multiplication is always the answer you got from the division times whatever on the front. So we're going to, or the bottom. So we do 3x times x minus 2. And when we already know how to do this, just distribution. So we do 3x times x, which gives us 3x squared. And 3x times negative 2, that gives us negative 6x. So if you cannot do that in your mind, you can just write down one more step. Okay, now this will line up with what we have. And now we're going to do subtraction. We need to be careful. When we do subtraction, we're subtracting this whole thing from that whole thing. So that's why I put parentheses here. And notice that when we do subtraction, we need to get rid of parentheses. So 1 in front of it, it's not going to change anything. But negative 1 in front of it will change the signs here. So this positive 3 becomes negative 3. And negative 6 becomes positive 6x. So there will be sign changes here. And then 3x squared minus 3x squared, they canceled. And negative x plus 6x gives us 5x. Because negative 1 plus 6 is 5. So you can do it horizontally on your scratch paper. If you don't want to do that, you can work vertically here. But remember, we have to do subtraction. So when we do subtraction, there's going to be a minus in front of both of these terms. So we're going to have to subtract this from the top and subtract this from the top. And with numbers, we usually don't have to put minus sign in front of it. Like we don't have to put minus here because we all remember it's minus. But with the variables, since we have negative numbers already, so we do have to put there, otherwise we may make mistakes. I mean, it's not required, it's not mandatory to put a minus here, but it's highly recommended because if I notice some students, they just forget that, they're doing subtraction. So if you put a minus here, you will not forget. Okay, so now we do 3x squared minus 3x squared, they cancel. And then when we're doing negative x minus negative 6x, and okay, so this is like doing minus minus, two minuses will become a plus. So this is going to be turned into a plus sign here. So we're actually doing negative 1 plus 6, which is positive 5x. So a common mistake students make is, because they didn't put a minus sign there, they didn't remember to do subtraction here, 3x squared minus 3x squared, they cancel. But when they get here, they forgot they also have to do subtraction here. So they're doing negative 1 plus negative 6 to get negative 7, which is incorrect. Again, when you don't put anything, you may forget. You're thinking you're doing subtraction because of the minus sign, but you are supposed to subtract the negative 6 from negative 1. So there's another minus sign you should have between them because we're doing subtraction between these two numbers. So when you already have sign numbers and you also need to do subtraction, it's better to put a minus sign there. Okay. So a quick tip is, so once you finish multiplication and you put your answer here, I would suggest that you immediately change the signs. And why do we change the signs? Because we're doing subtraction, so you need a minus in front of 3x squared. But why did we change minus 6 to plus 6x? It's because when you have another minus in front of minus, two negatives make a positive. So that's why you just change the sign. So this is a good tip that will help you avoid mistakes. So when you write down the multiplication step 2, answer from step 2, change the signs. So now you're just doing 3 minus 3 is 0, negative 1 plus 6 is positive 5. After we finish subtraction, we do bring down negative 5. So we repeat the process one more time. Again, this time we are focusing on the new expression 5x minus 5 divided by x minus 2, because every single time this is always what we're dividing by, just like we always divide by 12. and 12 goes into whatever, how many times. So here we always divide by x minus 5, x minus 2. So when we divide 5x minus 5 by x minus 2, so again, with 2 terms by 2 terms, it's not easy to divide. So we're just going to ignore the second terms. So we just divide 5x by x. That's much easier to do. So 5 divided by 1 is 5, and x divided by x cancel out. So we get a 5 and put a 5 on top of the line right here. So that's our quotient. But after division, we're going to do multiplication. We take the answer we got from step 1, multiply by the bottom or the one on the front. So you distribute, you get 5x minus 10. And we're going to take this and line up with what we have for under 5x minus 5. Now we're going to do subtraction. So in order to help us avoid mistakes, I recommend that you immediately change the signs. So 5x minus 5x cancel out. Negative 5 plus 10 is positive 5. So this is our remainder, and that is our quotient. Now it depends on what the question asking for. If they ask you, found the quotient and the remainder, so now you can just say, okay, after I divide them, I get the quotient, 3x plus 5, right here, that's the quotient. And I got the remainder, which is 5. But if they want you to write the answer as expression, so you will write down 3x plus 5 as the quotient, plus, because there we do have a little bit extra, which is 5, but we cannot continue the division, so we're just going to keep it as a fraction, 5 divided by x minus 2. Now, why is it like this? So just give you a simple example, like for example, 7 divided by 2, and we know 7, when you divide 7 by 2, you get 3 times and the remainder 1, and the answer is that 1 doesn't go into 2, but you can still keep it as 1/2, because 7/2 equals 3 plus 1/2. Okay, so that remainder 1 and divide by 2, we just didn't continue the division, but it's still supposed to continue to do the division. So that's, you can write your answer 2 different ways. You can say the quotient is this, remainder is this, or you can use this expression. And they are in calculus class, usually this is what we need, because it turns this complicated one into a simple one, a very simple quotient.